podcast. I'm your host, Nick Jikomes, and today I'm speaking with Dr. Selina Wang. Selina is a food scientist and chemist at the University of California, Davis, where her lab studies things like food quality and purity in vegetables and fruits and cooking oils and other things. So I talked with Selina about some really interesting and I think practically useful topics. We talked about how food quality and purity is actually measured in a scientific sense, what scientists actually look for when they're measuring and analyzing these things. We talked about cooking oils, olive oil, avocado oil, vegetable oil. We talked about some of the studies she's done on those things and how often they find impurities and freshness in those food products. We talked about oxidation of fatty acids found in some of those oils and what that means in terms of freshness. We talked about purity in the sense of how often adulterated products are actually found on shelves. So in other words, how often is a bottle of olive oil going to contain not just olive oil, but potentially other oils as well? She gave some really unsettling examples that her lab has uncovered of various types of food oils being adulterated, sometimes to extraordinary degrees. And it turns out this is a fairly widespread problem. There's actually a high percentage of food products that we buy at the store that are either impure in the sense that they've been adulterated with other things or are not fresh, meaning that either because of the manufacturing process or how long they've been sitting on shelves, they've gone at least partially rancid and are no longer as fresh as you might hope. So if you're interested in food quality and safety, as I think everyone is to some extent, this will be a great episode for you. She gave some really good tips that she uses for how to select things like olive oil or other cooking oils based on their freshness, based on the type of container that they're found in, and how to store and use these things to keep them as fresh as you can for as long as possible. As always, if you enjoy the content I'm producing on Mind and Matter, please like, share, and subscribe. Don't forget to check out the free weekly Mind and Matter newsletter at my Substack, which is at mindandmatter.substack.com. You'll get podcast updates and other information there. You can also check out not only the podcast, but some of my long-form writing on that Substack. Hey everyone, I want to take a minute to tell you about a product I use called Everyday Dose. They have created excellent coffee and matcha products with functional mushrooms and other supplements and less caffeine than traditional coffee or matcha products. I actually reached out to them because I've been using their product for about a year or so, and listeners often ask me about my daily and weekly diet habits. They make a really good mushroom-based coffee alternative. It contains micronutrients with antioxidant and anti-inflammatory properties, as well as collagen protein to help support healthier skin, nails, hair, and joints, and the amino acid L-theanine from tea leaves. Each cup has just about 39 milligrams of caffeine. That helps eliminate the caffeine crash that can come if you drink regular coffee, which has much higher caffeine levels. And they use a unique cold extraction process that results in lower acidity than normal coffee. And the caffeine microdose makes it suitable even for someone who doesn't normally drink coffee. This mushroom-based product is made using a double extraction from 100% mushroom fruiting bodies like lion's mane and chaga to maximize the extraction of micronutrients like beta-glucans, triterpenes, and sterols. Other brands don't typically do this, making Everyday Dose one of the highest quality products of its kind. It's gluten, dairy, and nut-free. There's no added sugar. It's paleo and keto-friendly and made with kosher ingredients. There are no grains or fillers, and it is lab-tested to ensure quality. I really like the taste of Everyday Dose compared to black coffee and other mushroom coffees, and they have a mushroom matcha product loaded with functional mushrooms and collagen proteins, so if you like green tea matcha, you'll probably like that product too. If you're interested in a healthy coffee alternative, I highly recommend giving Everyday Dose a try. Check out the link in the episode description or visit everydaydose.com to learn more. If you go there, you can find special offers that they have for getting a free frother and free travel pack of on-the-go doses with your purchase. This episode is supported in part by Athletic Greens. Their main product, AG1, is a comprehensive and convenient daily nutrition product containing 75 vitamins, minerals, and whole food sourced ingredients with less than 1 gram of sugar per serving, no nasty chemicals or artificial anything. It's gluten and dairy free and compatible with paleo, vegan, vegetarian, and ketogenic diets. AG1 is a quick and convenient way to supplement your diet to help ensure your body is getting the nutrients it needs. It comes in powder form and you can mix it in water and drink it, or you can put it into a smoothie or a shake or something like that. I mix it into water and drink it with the first meal of each day, and it's super convenient. If you go to athleticgreens.com/mindandmatter, Athletic Greens will give you a free 1-year supply of vitamin D and 5 free travel travel packs with your first purchase. Their vitamin D product comes in tincture form, so you just take 1 drop each day. A large fraction of the population is actually vitamin D deficient, especially in winter months when we get less sun exposure. And vitamin D is super important for the proper function of the immune system and for a variety of other things. And there's even evidence indicating that vitamin D deficiency is correlated with more severe cases of COVID-19 in those who get infected. Every time I go into the doctor each year for a checkup, I'm always told that vitamin D deficiency is very common and I should be supplementing on a daily basis. So visit athleticgreens.com/mindedmatter or click the link in the episode description. You'll get a free 1-year supply of vitamin D with your first purchase. And with that, here's my conversation with Dr. Selina Wang.
Yes.
And can you tell me a little bit about what kind of scientist you are and what your lab studies?
Sure. I guess depending on when we're talking about. So I actually came to University of California in Davis for graduate school, and I study in the chemistry department doing physical organic chemistry work, and which is just another way to say that is using computational modeling to understand reaction mechanisms. And I loved it. I did that for 5 years. And towards the end of my PhD career, I started to think about what I want to do as a career. And a lot of people that was studying some similar to what I was doing would end up in a pharmaceutical company, can study drug designs and other things. But somehow I always loved food, and I wanted to connect my knowledge and my passion together. So I decided to do a postdoc at the same university and in a different department this time, at Department of Food Science and Technology, which I didn't know even existed when I was an undergrad, because not every university has such department. But luckily, UC Davis has one of the best ones in the world. So I basically started learning all about food science, food chemistry. And at that time, it just so happened California started investing olive crops for oil production. And given our university is big on agriculture, and there was a need to support this kind of work. And so they looked at me, they say, "You're a chemist, right?" And I say, "Yes." And they said, "Great, you can study olive oil." And they didn't know that I was a physical organic chemist, not exactly an analytical chemist, which is what they were thinking of.
Mm-hmm.
But, one can learn. So basically, we started learning how to study oil quality and purity. And that was in 2008. And that basically changed the trajectory of my research interests and career pathway, because started as a physical organic chemist who studied very fundamental science to basically transitioning to more of an analytical chemist, study very, very practical and applied work. And so several years later, I now is a faculty in the same department that I moved to. So that's all to say, I never left UC Davis after I came here for graduate school. I just moved to a different department. But what I'm doing now is far from away from what I did for my PhD.
So you basically you started out as a hardcore basic scientist, physical chemist, and through the path that you took, you became a food scientist using analytical chemistry and techniques from chemistry to actually understand food and food quality and things like this.
Yeah.
And what exactly is food quality and how is it measured?
That is a great question. Of course, it really depending on the crop, so the particular food we're talking about, right? And also depending on where you are, right? Because depending on what you can afford, that's also something to take into consideration, right? And so it's hard to say these are the standard parameters that we look for all the food, because it really depends on what we're talking about, right? So if we go back to the olive oil example, when we started, we look at parameters that for quality, it's oxidation, right? Oxidation, because oil is mostly fats, and fats are they're going to oxidize just with time, right? So obviously there are factors such as light or temperature that will speed up the oxidation process, but it will just happen with time, even if you store it properly. So oxidation is something that we know that it will deteriorate this product, right? So for olive oil, for example, that will be a quality parameters. Now with other foods, let's say tomatoes, for example, people want freshness, people want sweet, people want nice texture. So in those cases, organic acids or sugars may be part of the quality parameter. So it really depending on what consumers are looking for. And also keeping in mind what makes sense, right? We don't want to generate so much food waste because we set the bar of quality at a certain level, and that is sometimes unnecessary.
I see. So when we think about food being fresh or food going bad, at a very basic level, what that means is chemistry has taken place. The chemicals that are inside of a food, whether it's olive oil or anything else, they've been changed in some way. And the way they change is going to depend on the food and the environment that it's embedded in. So you said in the case of olive oils and probably other similar oils, a really good measure of whether or not it's fresh or it's gone bad is oxidation, because these oils are prone to being oxidized. And so what causes this oxidation to happen? Is it the presence of oxygen? Is it heat? And, why does it matter? Does it change the taste of the food? Is it purely like an aesthetic thing? Or does it also change other aspects of the chemistry in ways that can impact human health?
Yeah, so oil is mostly made of triacylglycerols. So when oxidations occurred, these triacylglycerols will start breaking down, and then they will make compounds like peroxides. And peroxide itself doesn't have taste or smell, so it's not something that we will experience. But it can further break down to small aldehydes, and those aldehydes actually have unpleasant smells, such as rancidity. So if you have ever had stale walnuts, nuts tend to oxidize pretty quickly. So it has a smell that's almost kind of plasticky, and that is a smell of rancidity. Now, people debate about the actual health risks of rancidity, but there hasn't been a lot of concrete data on that. And of course, we're always careful about the concentration too, right? All of us at some point have had rancid food. Mm-hmm. It's a natural part of living, and our body is also oxidizing, right? I mean, mm-hmm. it's part of being alive.
Yeah.
And then, yes, so basically these fats, they will oxidize in presence of oxygen. And this is why, so for example, if you buy a bottle of olive oil and once you open it, the oil will start deteriorating, because once you open it, the oxygen can get into the headspace of the bottle. So not into the oil, but just in the empty part of the bottle, in the headspace. And that will interact with the oil in the bottle and then speed up oxidation. So the oil that is completely closed, it's never been opened, will have a longer shelf life compared to the oil once it's open. And this is always why when I talk with consumers about purchasing olive oil or any oil in general, is that don't buy a huge bottle if you live by yourself, and you will not be able to consume the oil in 6 months, because once you open it, you're going to start oxidizing the oil, right? And as you consume more and more oil, there's more and more empty space in the bottle. Yes. So then there's more and more oxygen that can get into that empty space.
I see.
It will speed up the oxidation.
Yeah. So if you buy a bottle of olive oil, as soon as you open it, oxygen can get in, and that oxidation of that oil will start to happen, and the oil will start to go bad. As you consume more and more of the oil and it gets lower in the bottle, there's more space for more oxygen to get in. So the rate of oxidation increases as you go from the newly opened bottle to the nearly empty bottle.
Exactly. And this is why I am a big proponent of the bag-in-box packaging for olive oil, which you've seen for wine, the box wine, that people sometimes associate that with low quality, using the word quality here, for wine. But we know that's not true. But if you had actually had box wine, a lot of them are actually quite good. But that packaging system, right, does not allow the oxygen to get in when you dispense the liquid or the oil. So that's actually one of the best packaging system for oil and for wine too. But the challenge with that is twofold. One is consumer perception. Consumer don't tend to associate that with high quality product. They still think glass is the way to go. And second is it's expensive for processors to do. So.
I see. But so going back to the oxidation and rancidity question, when oils become oxidized, they go rancid. Chemically, what that means is the oils change, and you start to get things like peroxides and aldehydes. Aesthetically, what's changing, or on the sensory side, is you can taste and smell the difference. Your olive oil will stop smelling like fresh olive oil. It'll start smelling bad, basically, and it will certainly taste rancid. And, in terms of the health effects of this, there's just two things I want to touch on here. One, our sensory systems evolved for a reason. Right? We're meant to be attracted to things that taste good. We're meant to avoid things that taste bad. And so, evolution has embedded in us the avoidance of things that taste rancid, because that can indicate either, the presence of microbes or the presence of things like aldehydes, which we're probably not supposed to ingest. And so even though you said it hasn't been well studied whether these aldehydes and this rancid oil has health effects, it would be absolutely shocking to me if that wasn't bad for you. I mean, aldehydes, they're one of the primary things in cigarette smoke that's bad for you. Aldehydes are just bad. And so it sounds like, oxidized oil is not good. Is that a reasonable conclusion, to draw?
I would agree with that, although with the caveat that in a very fresh, very, very high quality extra virgin olive oil, it also has aldehydes. Because depending on what aldehydes we're talking about, they can actually be very pleasant aroma, such as kind of grassy and green apple, stone fruit, the kind of pleasant, volatile that one will want to experience from a very fresh extra virgin olive oil.
I see.
Now, and then the really interesting part of all this, and it's complicated. The whole, the volatiles in foods is quite complicated, and the reason for that is because these volatiles, they can behave very differently in depending on the concentration. So at a low concentration, they can be pleasant, and then the same compound at a high concentration, it becomes unpleasant or a completely different kind of sensory experience. And also depending on the matrix. So if there are in a more oil-based matrix or a more water-based matrix, and then they would have a different smell as well. So
I see. So,
yeah.
some aldehydes can smell pleasant at a low concentration and actually smell unpleasant at a high concentration. And presumably they can also have different physiological effects in a concentration dependent manner as well. That would be my guess.
Yeah, yeah. And it's not exactly an area that's easy to study. So, I think we're still not me per se, but the scientists are still trying to learn more about it.
Okay. I want to talk more about olive oil. It sounds like that's been a major area of study for you. So before we get into like quality and freshness stuff a little bit more and adulteration and things like that, can you give us a little bit more just about olive oil? So, I use a lot of olive oil. I love olive oil. There's all different types of olive oil. There's extra virgin olive oil. There's filtered and cold pressed olive oil. There's all of these different types: virgin, extra virgin, all that stuff. What are the basic types of olive oil, and what do those things actually refer to?
Yeah, I wish it's not so confusing and complicated. And this also kind of depend on where you live. So in the US, we're very fortunate. I think you agree that we have access to high quality products. And when you say that you cook a lot with olive oil, I'm assuming you are talking about extra virgin olive oil. And extra virgin olive oil is basically mechanically pressed or centrifuged oil, meaning that you think about how orange juice is made. So I will just walk you through the process really quickly for extra virgin olive oil. Basically, you harvest fruits at proper time. So before they become overripe, you process the fruit at the optimum time, and you bring them to the mill within ideally 24 hours. Because if you wait for too long, then the fruits can start fermenting. Ideally, I think most processors will do it 6 hours even. So you want that time to be as short as possible. Bring them to the mill, and they can go through a washing process, although some people skip that part if the fruits are pretty clean. And it will go into the crusher with the skin and then the pits. So the entire olives will go into the crusher and basically grind it up into more or less like a paste. And then the paste will go into this thing, which is called malaxer. Malaxer is basically a equipment that kneads this paste for about 45 minutes to an hour, depending on the processor. And what happened during this malixation process is the small oil droplets start to coalesce and forming large oil droplets. And then that going to the centrifuge where the oil filters out and everything else goes the other way as olive oil byproduct. And that oil is extra virgin olive oil. So basically there's no heat, there's no chemicals added. It's very much like how you make orange.
It's just a physical, mechanical process of basically squeezing the oil out.
That's right. That's right. So that's extra virgin olive oil. And, you still see bottles that says cold press. Actually, I don't know anyone is pressing the oil in California, and very few in other places too. But consumers research have shown that people associate high quality olive oil with the word cold press. Mm-hmm. So even though most of the oil is centrifuged out, the word cold press remains to be on some bottles and on some labels.
So essentially, they're just spinning it around very fast to separate the oil. There's no cold pressing happening in the way that people normally imagine. So that's basically just a marketing label.
Yeah. And, I much prefer centrifuged oil than a pressed oil because with the pressing, it was actually very, very hard to make good oil because it's impossible to make those things clean to clean the process. Where in the centrifuge, it's a much cleaner system.
Okay, so you sounds like you personally don't care about whether something's labeled cold pressed or not.
No, yeah.
And what's the difference between virgin and extra virgin?
Yeah, so that in the US, virgin, I don't really see any oil with virgin on labels.
Okay, so it's pretty much all extra virgin olive oil.
Yeah, I don't think in the US there's a market for virgin olive oil. But in terms of definition, basically olive oil or extra virgin olive oil is an olive oil that has no sensory defects. And virgin olive oil is an olive oil that can have a little bit of sensory defect. So olive oil is one of those very, very few food products that actually has sensory in the quality standards. Earlier we talked about what is food quality, right? Most of the parameters are based on physical or chemical. Olive oil is very, very unique in that sense. There's a physical, there's chemical, and then there's a sensory in the official standards. And the difference, sure, there's a little bit of difference in terms of the chemistry standards between virgin and extra virgin. But mainly it's the small sensory defect that is what make an oil to be virgin instead of extra virgin.
I see. And so that just means the difference is really just fairly minor differences in the way they taste and smell.
Yeah, exactly.
Interesting. Okay, so now we know what extra virgin olive oil is. That's the thing you'll run into most of the time at the store when you buy it, at least in the United States. It's just olive oil that's been physically separated from the rest of the stuff, from the olives that it's derived from. But when I walk to the store and I go buy olive oil, there's many different brands out there. And sometimes the prices vary a lot. Some of it's quite a bit more expensive than other stuff. So when we think about quality, not just in terms of the composition, or the freshness of the original material, is there anything else to quality that we have to think about, like purity and whether or not it's been contaminated with other things in the process of actually making it?
Yeah, there's a lot to cover there. Before we go into that, though, do you want to talk about refined olive oil?
Oh, yeah, let's do that.
Because that's part of the reason that may cause the price differences too. So refined olive oil is actually quite different from extra virgin olive oil because it includes a completely separate processing step that is refining. So canola, soybean, vegetable oil, all those oils, without saying on the labels, they're all refined, which is what gives them the light, pale, almost transparent color, right? So where extra virgin olive oil still has the green hue and basically an oil that is what they call a lampante, which it means not fit for human consumption. And that can be oil that's made from really, really bad quality fruit. So the fruit that either has significant pest issues or fruits that are so overripe that there's all kinds of sensory defects like fusty, musty, that's come from fermentation of the fruit. And then they would go through the process we talked about for extra virgin, right? And then after that process, they realize this oil is not extra virgin or virgin, so you cannot sell it, right? So you will take this oil to refining, to a refiner. And what happened during refiner is that they would basically use heat and some chemicals to remove all the sensory defects. And they will add something to neutralize the fatty acids in there so that it basically lowers the free fatty acidity, and then it removes all the peroxides that we talked about from oxidation. So basically, the result is a very mild, bland oil, and that is what refined olive oil is. Now, if you go to the supermarket and you buy, in the US anyway, there's pure olive oil, and there's also extra light olive oil. And that is basically consists of most refined olive oil. And then you can tell by their color.
I see. So if I'm hearing you correctly, when a food oil or cooking oil, whether it's olive oil or something else, is refined, whether or not it says that on the bottle or not, when it's refined, that basically means it was subjected to additional physical and chemical processing other than the original process we talked about for something like extra virgin olive oil. And the reason it needed to be subjected to that additional processing, that refinement, is because the starting material was considered unfit for human consumption.
Correct.
So anytime an oil is refined, it's an oil that was processed physically and chemically from something that is considered unfit to put inside your body.
Yes. Or no one will want to eat it.
Yeah. Okay. And so by default, that's a lot of vegetable oils.
Yeah.
And some olive oil.
Yeah. Yeah. So during this process, the negative sensory, the chemical compounds that are responsible for the negative sensory attributes are removed. But in the case of olive oil, the pigments are also removed, right? So that's why it's not green anymore after it's refined, along as with the antioxidants. So the natural phenolics, they're also removed.
I see. So you're removing bad things as well as good things.
Yeah, that's right.
And well, so here's the next question I have now. If in the process of refining a cooking oil, you have to subject the starting material to heat and other forms of chemical treatment, wouldn't that inevitably lead to some oxidation of the actual oil that's going to remain in there?
So the process for refining has been worked out for a long time. And I think they're able to control the process where it basically very little natural oxidation is going to happen. So I because if you analyze the oil after it's refined, it doesn't have really the oxidation markers that we usually look for. They're not there.
So those things have been measured in fresh refined oils, and when you initially crack open the bottle, there's no evidence of oxidized fats in there.
Right.
I see. Okay, so we did some background on different types of olive oil and some other stuff about other oils. Now let's talk about some of the work that you've done actually looking at olive oils that you've tested for things like purity and freshness out in the wild, so to speak. So I believe you've done some studies where you've gone out and I think purchased some olive oils from different brands and things like that, and looked at whether the olive oil really is olive oil and whether it has the properties that you would expect it to have based on how it's labeled. Can you tell us a little bit about that work?
Yeah, so it was in 2008, and that was my postdoc work when I really was just starting to learn about olive oil quality and purity. And at that time, there were scientists who work in Australia that they've been studying this for longer than we have. So we learned how to do some of these chemical analysis from them. And I basically went to supermarkets all over California, and just like any consumer would, stood in front of the aisle, completely feel overwhelmed and confused and don't know what to buy. But in this case, I just bought every single one of them. And in 3 bottles or more, because we want to have duplicate samples or triplicate samples. And we brought them to the lab. We did quality analysis, which is mostly basically tell us if this oil is fresh or it's oxidized. We also did purity analysis, which in this case, we follow the official methods for olive oil. They're basically looking at their fatty acid profile, because fatty acids are what's in the oil, basically. And each different oil, so vegetable oil, so soybean oil, canola oil, all the different oil, they have different fatty acid profile. So by looking at that, you can see if it matches with olive oil or it matches more like canola oil. And then in addition to that, we also look at their sterols. So cholesterol is the most common sterol that people know, but there's also many other plant sterols that's present. So similarly, different seed oil or other type of oil have different sterols composition and profile. So comparing the one that it should be, what should look like for olive oil to canola, soybean, you can see if this oil is actually made from olives or it's adulterated with other oil. So those two are the primary methods that we use to analyze purity. And then we mentioned that sensory is part of the official standards for olive oil. So we also send samples to a trained panel. So this is not like, we ask consumers on what they think about this oil. Do they like it or do they not like it? This is a trained sensory panel where they basically calibrate themselves to be like analytical instruments. So they've been trained on given, say, rancidity, which is one of the most common defects for olive oil. They are able to say on the 0 to 10 scale how rancid it is. And the panel is calibrated to the same degree, basically. And it requires at least 8 panelists to participate. So that's how we did the work. So we have quality, purity, and then from the lab, and work together with a sensory panel. And that work, we published it in 2010. And that, kind of started the whole thing about, I guess, raising people's awareness about food quality and potential fraud in these high value products.
Yeah. So you tested all the products, and I'm guessing you did not find, I'm guessing you found some unsettling results.
Yeah, my favorite one. So, well, it's favorite because it's shock value. It was actually the one. So we did that, study that we mentioned. I went to the supermarket, and then after that, I then worked with the university dining services to look at the quality and purity of the food service oils. So the ones that restaurants purchase, the one schools, cafeteria or hospital cafeterias purchase from, right? Usually the quality or purity from food service is worse than what we get from retailers.
I see. So basically places like schools and hospitals or things like that tend to use the lowest quality oils, even lower than what a regular person is likely to purchase at the store.
It's truly unfortunate, but it's an economic concern, right?
Okay. So that would imply, if this is an economic thing, right, is low quality highly correlated with the price?
Not always. But I think it's because there's some people are just really, really greedy. So, and we've seen that in different cases, but we'll go back to that in a second. So the one sample we got through food service was this oil that was neon green. It almost looked like it would glow in the dark. And the green was hard to describe. Fresh olive oil would be green, but not that kind of green. So when we got this oil, I could not wait to bring it to the lab. I wanted to learn everything about this oil.
Yeah. So just by looking at it, you were like, what the hell is this?
Yeah, exactly.
It can't be olive oil.
Yeah, and so it turned out it was 70% canola and 30% olive oil. But that is not the worst part. The worst part was it had artificial copper chlorophyll. So it's different from the actual natural chlorophyll that you would see in olive oil that makes extra virgin olive oil green. It was an artificially added green color. So it's they go
I see. So the manufacturer,
yeah.
so it's 70% canola oil, 30% olive oil, and it's got this adulterant in it. So basically, whoever manufactured this took something that was mostly canola oil, added an artificial version of chlorophyll to make it look green, which turned it into some kind of like Teenage Mutant Ninja Turtle ooze color by your description, and then labeled it and sold it as olive oil.
Yeah.
Okay. Yeah. Well, I mean, I think we'll get to questions about regulation later, but give us so I mean, that's one striking example. Can you give us some statistics here? So how many different types of olive oil did you look at in this study? What percentage of them had a significant level of impurity? What percentage of them had a significant level of adulterants?
Yeah. So I would say, so first of all, this study was done 15 years ago, right? It's been 13 years since those reports are published, although I still get emails weekly from people who just read the report and then ask me what brand of olive oil they should buy, right? But I would say that the quality and the purity of the olive oil available in the US has increased, has gone up significantly. And actually, it's hard now. So I've been asked if I should repeat a study because I think it's frustrating for some companies that people keep bringing up this study that was done 15 years ago, right? So there's some interest to basically revisit and see if we will get the same results. My sense is not, we will not.
But but give us some guideposts here. Like, if you did this study back in 2010, it was published. If 10% of the samples had impurities in them, and we've gotten better from there, that's a very different story than if 60% of the samples in your original study had impurities, and we got a little bit better since then. So in the first study, knowing that this is a few years old, what percentage of samples had significant impurities or adulterants added to them? 50%, 80%, 5%?
Yeah, no, I would say, so in the report, we said about 68% of imported, so any oil that were not made in the US, did not meet the USDA quality standards, meaning that they may be pure, but they were oxidized.
I see.
And in terms of the oil that were not pure, it was definitely lower than that percentage.
I see. So another way of saying that is at the time of the study, around 2010, almost 7 in 10 olive oil samples had either gone bad, had some level of oxidation, and or contained adulterants, other types of oil inside of them.
Yes. And I would say, add to that, it's hard to use price as a quality indicator because there's a lot of times an oil that is actually really good, and that's why they were basically marked at the higher price point, but they don't sell, right? So they sit on the shelf at a grocery store for a long time. And the product sits there for 6 months, 9 months, and it's oxidizing with all the light from the store. And also, a lot of times they're not in an aisle that's very cool. So the temperature, the light is oxidizing the oil as they sit on the shelf. This is one of the reasons that I think the oils that are higher in price sometimes do not do well in
I see.
their quality after.
It's not that it was a poor quality product when it was made. It's that the high price means people don't buy it for a long time, and sitting on the shelf is really the issue.
Yeah, and the same reason I think contribute to a higher percentage of imported oil to be lower in quality compared to domestic oils,
Just because it takes extra time to get over here.
right.
Okay, so if you were to create a rubric for someone for how they should go to the store and select which type, if they want extra virgin olive oil, what would you say? It sounds like you would say get something that's not imported, get something that is, what would you say?
I would say freshness is key. So I would look for an oil that is made in the most recent harvest, right? So if you choose to buy from California, you would look for harvest in June now of 2023. So the most recent harvest would be the fall of 2022. So that would be the most recent harvest.
And is that always printed on the label?
Not always. So this is the tricky part. I think more and more producers, 15 years ago, very few, maybe one or two companies were doing that, but more and more people are realizing the importance of that information for consumers. So I would look for the most recent harvest day. But also if the bottles doesn't have it, I kind of feel like, well, maybe they don't want me to know.
That's a bad sign. Yeah.
So that is most important to me. I actually buy oil from all different countries. I enjoy the diversity in different origins. I also enjoy the diversity of different cultivars. So, currently the olive oil industry is kind of like you go to a wine shop and there's an aisle of red wine and then there's the aisle of white wine, or maybe just one aisle that says wine, right? But in reality, right now you go to wine, there's different variety of wine to choose from. So, and it should be the same for olive oil, because they actually taste quite different. And they may pair your cooking or baking differently too, because their sensory profile. So for me, freshness is key. So I look for the most recent harvest. If it doesn't have that, I'll go by the best before date. So the oil that's as far away from its best before date. I also care about the price. So if it's a price that I can buy other, different brands, and I can get 5 bottles of those, that's important to me too. And and then the packaging. So I would avoid buying oil that's in plastic or clear plastic. And usually most of oil now is in a dark green glass. That's a good container, or in a tin can. That's a good container. And then we talked about in the box. That's a good container. But yeah, I would avoid buying anything that's in
plastic. So you want it to be in material that protects it from light.
Right. And then plastic is also porous. So you will actually allow oxygen to get in as well.
I see. Well, so you said that you like the packaging where it's a bag and a box, but isn't the bag made out of plastic?
Yes, but there's actually a liner between the oil and the plastic.
I see. Okay. So you want glass, like the tinted glass that filters out some of the light, or metal a can or bag in a box. That's better than clear glass.
Yes.
And better than a plastic bottle.
Yes.
Okay, so you want that for your container. You want it to be as fresh as possible based on the harvest date or the sell-by date. Anything else in terms of?
So size it right. So if buy it where you will be able to finish in 3 or 4 months, ideally, or even
as small as reasonably possible.
Because the natural antioxidants will start decreasing, right? People buy olive oil for flavor and for health. Right. So the flavor is at its best at the very beginning, and the health benefits are also at its best at the very beginning. So you want to buy the bottle that you can finish consuming as early as possible.
And how what are your feelings on the refined olive oil?
I think there's a place for refined. There, for a while, the price of extra virgin and refined were very similar, and that is a little that was partially due to adulteration and other issues. I think that has improved quite a bit for olive oil. So if refined olive oil is cheaper than extra virgin olive oil, which should be the case, then I think there's a place for refined olive oil as well.
It's, at the same time, though, based on what you told me about the refinement process, if the refined olive oil lacks the natural antioxidants that the unrefined olive oil has, wouldn't that mean that it's naturally going to go bad faster?
So partially, yes, but also the refined olive oil still has the same fatty acid profile as extra virgin olive oil, which means that it's mostly monounsaturated fat, which is heart healthy, and it doesn't oxidize as fast as polyunsaturated fats. So refined olive oil itself still has a decent shelf life.
I see. So olive oil in general, because it's high in monounsaturated fat and low in polyunsaturated fat, has a shelf life that's longer than something that's mostly polyunsaturated fats.
Yeah. So like macadamia oil.
I see. Okay. So those are quality. You've got the harvest date or the sell-by date. You've got the type of container that it's in. And you've got the size of the bottle. Once you have these things at home, how do you store your olive oil? Is it on the counter? Is it in a cupboard? Is it in the refrigerator?
Yeah, so I store it in the cupboard. So you want to keep it away from light and heat. It's tempting to put it right next to the stove, but that is really not a good place. And some people would store it in the fridge, but if you cook it every day, multiple times a day, that really is not a practical way of doing it, because some part of oil could become, could solidify, right? Now, if you have found, so for example, if you go to an olive oil tasting, which people do here in California, like they do for wine tasting, they go to an olive oil tasting, and you found this olive oil that you love, and you bought 10 bottles of it, and you bring them home, and there's no way you could finish using all 10 bottles. You may consider storing some of them in the freezer. And that is a way to preserve the antioxidants that's in them.
So if you buy 10 bottles of something, 10 small bottles, because we want to use it as quickly as possible once you open it, you can have the first one in the cupboard, and that's the one that you're using for your meal preparation. And then you would put the other 9 in the freezer until it's time to use them.
Yeah. And the oil, after you take the oil out of the freezer, it may never become fully liquid, right? But that's okay. That's just some waxes, or, that is not a problem.
I see. Okay. Interesting. Yeah, I think that's very useful. That's very useful information, I think. I didn't know most of this stuff until I looked at your work. What about other oils? I know that you've looked at other types of oil, and obviously people use all different types of oil. Vegetable oils are very common. Avocado oil. There's many, many different types of vegetable oils. What can you say about some of these other oils? Are when you did the olive oil study, are the problems that you saw with those olive oils that you purchased, is that unique to olive oils, or is this a more general issue?
Yeah. So when we started studying olive oil, that was kind of considered to be the most high value product, right? So anytime there's a high value product, it's at risk for adulteration. And when I was working on olive oil, I received emails from people in the avocado oil industry, from the hemp oil industry, where they have concerns about the quality and purity of the oils in their industry. So that's when I started considering taking on some of that work. We in our lab, we take the approach that we're not studying the health benefits per se, right? We look at the concentration of these natural antioxidants in terms of the chemical composition in different oils, but we are not doing, say, human clinical trials of these oils. But what we do care about is the label should match with what is in the product. So that's where our work has been, and we have since expanded to avocado oil, which we have published a few papers on that. And I feel strongly about helping the industry to also develop standards, right? Which is what's lacking for the avocado industry. The olive oil industry, in 2014, I helped drafted, along with other people in the industry, we drafted a standard for California, which is only applied to domestic producers in California. It's not a federal standard, so it's only a state standard. But that has helped a lot for the quality and purity of the products. So, having this kind of things, I think, helps the consumers to be more confident in the products they're purchasing. And we're hoping to do that for now avocado oil, but also other products in the future.
Mm-hmm. And in some of the more recent studies that you've done on avocado oil, what have been the results there in terms of purity and quality?
Yeah, so in 2020, we published a paper basically about 80% of store-bought avocado oil were either oxidized or not pure. So
actually a very similar result to the 2010 olive oil study.
Very similar result, but there was, in some cases, and I still remember that because I was sitting in the room that I'm in now with my graduate student, Hillary Green, who was the first author on all these work. And we're going through the data, and I saw something that I didn't see in all of my work with olive oil. That was, I think there were some companies were just really taking advantage of the lack of standards and knowledge in avocado oil, because they were 100% soybean oil labeled as extra virgin avocado oil.
So they were literally just putting soybean oil in a bottle and calling it something else.
Yeah. So in the case of olive oil,
who was that?
That company actually is no longer in business, I think.
Great.
Thanks to our work.
Who were they?
I don't remember the name, but I can find out.
Okay. Yeah, don't worry about it. Okay, so they're no longer business. That's good. Okay, so what else did you find?
Somebody took them down. Not me, but somebody did.
So this is not a unique problem to 2010, and it's not a unique problem to olive oil.
Yeah, so in olive oil, usually you see a blend of olive oil and something else, right? And in this case, it was 100% of the adulterant and something that's refined being mislabeled as extra virgin, which has very different processing steps. So that was very troubling. And also the price of that was very high. And we purchased it from one of the co-op health stores in town. So people who were paying for that product, I'm assuming, were trying not to buy soybean oil. I can only guess, but likely. And in fact, after we published the work, I received a lot of emails from parents who wrote to me and said that they either their children's doctors or they are trying to avoid soybean oil for their children for a variety of reasons. And they feel completely helpless regarding what oil they should buy because they were trying to use avocado oil in all of their cooking. And because my study, which cause a lot of fear in them, unfortunately.
What brands of avocado oil had the best purity and quality?
So in our study, so I need to be very clear that we were not able to collect all the brands, right? So that's one of the things in our first study. In the paper, we didn't list the name of the brands. We had sample 1, 2, 3, 4, 5.
We can talk about why that is.
But UC Davis follow up with a press release where in that press release, they commented on the brands that were tested to be pure and not oxidized. And it was Marianne, which we purchased from Costco. I think they still sell that at Costco, and Chosen Foods, which you can find that anywhere, basically.
Mm-hmm. So that's one good one. Was that the only one?
Marianne and Chosen Foods.
Those are like the two good ones that are easy to find.
They're easy to find. There's other ones, but there's some that I know they're pure, but they happen to be oxidized when we analyze them.
And that could just be because they didn't sell in time and they sat on the shelf, not necessarily because, the manufacturer did something wrong.
Yeah. And there were, after the study, some companies have reached out and asked, we published the lot numbers and all that information so the company can trace the products and they can see. And some of them say, that oil was old. We should have pulled it off the shelf. So some company used it as a way to improve, which, is great.
What were some brands that contained significant levels of adulterants?
So I mentioned the company that is no longer in business. And
I think it would be more useful for people to know the companies that are still in business.
I know. I can't remember the name actually on top of my head. I'm not trying to protect him, but I think I can't remember.
Is that information anywhere?
No.
Oh.
Yeah. This is
why?
part of, this is
What's the point of doing this?
This is part of the a discussion that I think is worthwhile having, right? So as a researcher, right? So when we publish the paper, the goal of the work is to demonstrate the need for standards, right? And we're not trying to police the bad guys in the industry, right? We're developing chemical methods and we are demonstrating there's a need for standards, and our lab is working on developing these standards. And
but you're effectively not releasing data. I mean, that's what we're talking about here. So you're not releasing data.
Correct.
I mean, how do you square that with your philosophy of science?
So we can debate about that, right? Because if we did, there's a lot of studies like this. People just list sample 1, 2, 3, 4, 5, right? There's so many studies like this. But what I got was for the consumers, like you said, a lot of consumers feel the same way you did. Also, there's no way for them to know if the oil that wasn't named as a good brand were they either not included in the study or they were bad, right? There's no way to tell that, right? So I actually consulted this with a campus council, and this is what we decided on.
I see.
Yeah.
Do any of these food companies contribute to the research funding in sort of the food science departments generally?
So the first study we did, it was funded by a company called Dipasa. And we collected samples independently. And It turned out their oil was not one of the good ones that their oil was pure, but due to packaging, their oil was
Oxidized.
when we analyzed it. It was not the results that they wanted to see. But they contributed to some of the funding in the first study. That was the only funding we received. And the second study that we just released most recently, which was a very similar study, but this time we focused on the store brands, because I receive a lot of emails from consumers about what about all the store brands, right? Which they tend to be a little cheaper and a little bit more accessible. So that's what the second study was basically. And that was, my student was funded on a fellowship, and then we use our lab's resources.
I see. So just to finish off on this, the decision not to publish the names of brands that are producing oils with adulterants in them is made by the University of California, Davis.
I consulted with them. I don't know if.
You consulted with your employer. So you did what they said.
I think the rationale, and I struggle a lot with this, is the rationale is that is not, we didn't do the study to find out who the bad guys are.
I comprehend what you're telling me, and I'm sure the lawyers worded things carefully.
Yeah, we wanted to demonstrate that there's a need for standards, but I don't think we want to be in the position of policing.
You're not in policing. So police enforce the law. That's what a police officer is. You would simply be publishing your findings, and that's what the process of doing science is. I mean, we don't need to dwell on it or agree. I just don't personally understand it. It sounds like a legal argument to me, not a.
Yeah, I'm trying to find the perfect, which I don't know if it exists. I'm trying to find the perfect way of doing this, because I will probably come across this again. So let me tell you what I did for the second study based on what I learned from the first study. So I think many people feel the same way that you do for the first study. So in the second study, what we did is, in the paper, we still have samples 1, 2, 3, 4, 5, but there's a supporting information where we list all the brands. But again, the brands are not tied to the sample number. So this time, one would know where the samples came from, what samples we actually analyzed, but we are not saying what oil tested well and what didn't.
So the information's there, it's just not in an actionable format.
Correct.
So going back to the olive oils briefly, because I forgot to ask you for that, what brands of olive oils had high purity and high quality?
Oh, that was 15 years ago.
Yeah.
So for that's actually in that we took a different approach in that was not peer reviewed. So the work of that California and imported olive oil study, it was not peer reviewed. It was published as an independent report by UC Davis Olive Center. So in there, it actually showed how each of the brand did.
I see. Okay, so that's in there.
Yeah.
Okay. Yeah, I'll try to link to that in the episode description so people can look that up. So besides avocado oil, olive oil, has your lab studied any other types of cooking oils?
Yeah, so we're interested in some refining process of different oils, right? So we have been mostly looking at extra virgin, so mechanically pressed oil, which we continue to do. We continue to study olive oil and avocado oil, but I'm also interested in refined oil because we will never be able to make enough extra virgin olive oil or avocado oil to feed the world. So if we can make vegetable oil or other types of oil healthier, a little better for us, either meaning by changing the parameters slightly, by imposing different quality limits or standards, we want to take a look at that, which a lot of people have been studying. Vegetable oil has, and all different kind of oil has been studied quite a lot in the U.S. and outside the U.S. But that is an area that we're also thinking of. But so that's one area. We're also focused a lot of our work currently on the byproduct. So the byproduct from making olive oil, and there's a significant amount of antioxidants that's in the byproduct that is not in the oil that we get to enjoy. So we want to find some valuable use in that. So there's a lot of work on that.
And besides cooking oils, does your lab look at other types of foods?
Yeah, we look at almonds, pistachios, walnuts, because naturally those foods are also high in lipids. So that was kind of an easy transition for us. But my job actually is to cover all the crops in California. So we also have projects on tomatoes, oranges, strawberries, and pomegranate. I'm sure I'm forgetting a bunch of things, but basically every crop that is we have in California.
I mean, is there any results that you can share with us that might be interesting to listeners around, the purity or quality of those types of foods?
For walnuts, so walnuts is one of those crops that suffer oxidation pretty commonly. And I think there's few things that the industry can use help with. So that's basically, storage, packaging, so which we've been helping. We're trying to help them to monitor oxidation and predict and coming out with chemical tools to predict oxidation and shelf life better for walnuts. And so this way, because sometimes, and this has happened to me, I don't know if it has happened to you, is you go to the store, you buy a bag of walnuts and then it's rinsed when you buy it. So something has already happened to it. And we want to avoid that kind of experience for consumers. So that's something we've been working on for walnuts. Another thing is there's mislabeling issues for walnuts, just like there is for other things. Mostly there are walnuts that were made in China that are mislabeled as California walnuts. So we've been developing chemical tools to differentiate California walnuts from Chinese walnuts or walnuts from other origins. So this is kind of a different type of fraud. It's not adulteration, but it's still fraud nonetheless.
Yeah. And I mean, this seems to be a very widespread problem to me for just consumables of all kinds, because like all the work that you've shared with us about foods, that's, you have found the startling things that you found. I know this is also true for things like health supplements. People have found that, the labels of health supplements often don't match. They're not the right dose, or they're not even the right thing. I've worked in the cannabis industry for a number of years, and I've studied the laboratory testing methodologies and results from that industry, and same issues apply there. And So, I mean, if I remember correctly, when we were talking about the olive oil stuff, I think you said that, a very large percentage of the oils that you tested didn't meet the standards that were already in place. And I understand you're trying to make new standards, but you can have as many standards and as rigorous a standards as you want. If no one is, enforcing the standards, then what's the point of it? So I guess I just want to ask you about what are your thoughts on not just creating standards using some of the scientific work that someone like you is doing, but how can we actually enforce standards in ways that ensure consumers are protected and they're getting what they're paying for?
Yeah, 100%. And sometimes I get very frustrated. In the case of olive oil, there are standards. There were standards before we started doing the work. The difference of California standard is it's mandatory. So the producers has to send their sample out to a third party lab and get the lab results. And my lab will actually review these results and we'll write a comprehensive report to the Olive Oil Commission of California, which California Department of Food and Agriculture will review. So it's a mandatory monitoring program, right? So that is very different from the voluntary standards that the USDA have. So I agree that standards without enforcement is not that useful. And currently the California industry has submitted a standard of identity petition to FDA that is different from the USDA standard, and it can be enforced if it's approved. But I don't know how many years we'll have to wait before that will become available. And so far for avocado oil, there's no official standards, and I don't see any enforcement soon.
I see. So basically, at the end of the day, the only way for a consumer to ensure that they're getting something that's high quality and they're getting what they paid for is to use some of the tips that you gave around looking at harvest dates, being conscious of the type of bottle and the size of bottle or container that something's coming in, and actually to basically train yourself to learn what things should taste like. Because it sounds, based on everything you've told me, if someone's going to buy a bottle of avocado oil right now, it's within the realm of possibility that they might be buying a bottle of soybean oil or whatever. And the only way for them to know that would literally be to taste it and be able to tell the difference themselves.
Yeah. And that is true. And if you have ever tasted or smelled a fresh extra virgin olive oil, you will know what that is like, right? And then it's hard to go back to the rancid, oxidized oil. And in the case of avocado oil, it's more difficult because most of the avocado oil in the US, unlike the olive oil industry, most of the avocado available to us in the US are refined, which means they are much more mild in their taste and smell. So it's hard to just try it and then see if it's pure or if it's good quality, right? I was in New Zealand a few months ago and they didn't have really a market for refined avocado oil. It was mostly extra virgin avocado oil. In that case, you can smell and taste if it's fresh or pure, but still extra virgin avocado oil is a little bit more mild and then it has this different taste and smell from olive oil, extra virgin olive oil.
Is there anything that you want to reiterate from what we've talked about, or any final thoughts you want to leave people with about food quality and purity, and how people as consumers should think about this, and the ways maybe that they can use some of this work to be mindful consumers about what they're actually buying?
Yeah, so I think a lot of people who do research in this area are doing what they can to help to move things forward. I think people get frustrated with people at USDA, FDA, or even me doing research, right? And we're making progress slowly, but resources is a challenge, right? So for many of us, and for things like standards and enforcement, it also really require the members of the industry to work together to want to improve, because it's a reputation of the entire industry, not just one brand, right? And this is partially why we try to stay away from pointing out a particular brand, because really is trying to focus on the industry as a whole and trying to help the industry as a whole, rather than to create more problems and prevent the industry to work together. So I would say that, and then for that's just coming from the researchers' point of view, and for consumers, it's hard, but I think a lot of us may be disappointed that our food are not as pure, or the labels are not always what they say they are. But I think, given the work that I have been doing, the 15 years, the people I have talked to, and we're moving in a more positive direction. The technologies are improving, so there will be able to help to detect quality and purity in a faster, better, and cheaper way, because that's one of the reasons why we cannot, or USDA cannot, test every single lot of product that's coming to the US, right? Because the testing is expensive and it takes time. But I think as technology advances, we can apply that to our food supply chain and then food system. So it's a big problem, but I think, putting more technology in this area, and which is where now people, at least, people care more about their food, where it's coming from, and the quality and the purity and authenticity of that, more than people had before, right? So that's, I'm optimistic about this, even though, I do see things like what we have studied.
All right, Dr. Selina Wang, thank you for your time.
Thank you.
Hey everyone, I want to take a minute to tell you about a really cool health monitoring device I've been using for several weeks. It's called Lumen, and it's a handheld, pocket-sized device with a sleek design. It measures CO2 levels in your breath, which allows their technology to determine the extent to which your body is burning fats versus carbohydrates. Lumen helps improve your metabolic flexibility, your body's efficiency in shifting between using fats and carbs. It improves your ability to burn fat, which decreases your hunger levels and makes your body less dependent on snacking, and it can increase your energy levels by helping you develop a high-functioning metabolism. I use this device in the morning, before bed, and after meals and workouts to track my metabolism. With just a couple weeks of use, I learned a lot about which foods were causing my body to burn mostly fat, mostly carbs, or both, as well as how long I need to fast each day to promote fat burning. Lumen is great for anyone looking to optimize their health for either weight loss or athletic performance. The easy-to-use app allows you to track your results together with what you're eating and how you're exercising, and it syncs with other devices like the Apple Watch. Click the link in the episode description to learn more, and use the code MIND, M-I-N-D, in all capital letters to get $50 off your Lumen device today.